So with chapter 4, or module 2 here that we're actually going to start looking at, we are working with systems of linear equations. So in module 1, when we were in chapter 3, we were working with just one equation, one linear equation at a time. And now we're going to sort of switch gears and we're going to work with two linear equations at a time. And thankfully, a lot of what we looked at in chapter 3, in module 1, is going to just transfer over and help us here in module 2 in chapter 4. So with question 2 here, we're told, in the following exercise, determine if the following points are solutions to the given system of equations. And we're going to look at what this means in subsequent Practice Makes Perfect videos, so hang in there with me. But right now, all we're going to do is we're going to determine if each of these points, point A and point B, do they satisfy the system of equations, right? So from chapter 3, we know what it means for an ordered pair to be a solution to a single equation, right? That means you can take that ordered pair, substitute the x and y values into the equation, simplify, and you get a true statement, right? That's what it means from module 1, from chapter 3. Well, now that we're working with a system of equations in which we have two equations, two unknowns, well, now we have to plug in each of these ordered pairs into both equations and determine, does the ordered pair, for example, the ordered pair, which is what we're calling A here, -5, -7, does it make the first equation true, and does it make the second equation true? And if it does, then what we say is that the ordered pair -5, -7 is a solution. And if it only works in one, and it doesn't work in the other, well, then it's not a solution. And of course, if it doesn't work in either of these equations, then it's certainly not a solution. So we are looking for true statements in both the first and second equation when we plug in point A, and then we're going to test point B. So enough rambling, let's go ahead and actually dig in. And we know, of course, that with an ordered pair, as I just alluded to a moment ago, the first piece, the first component is our x, the second piece, or the second component, is, of course, our y. So let's take this information and let's substitute it into equation 1 and see what we end up with. So for equation 1 here, we're going to have -3x, but of course we're now going to substitute -5 in for x, plus y, so plus y, and this time we're substituting -7 in. And we want to know, when we simplify, does the left-hand side equal 8, right? That's ultimately what we are testing. So let's do a little bit of cleanup here and see what happens. And of course we're going to distribute here, we'll distribute here. -3 times -5, oops, forgot to mute my phone there. -3 times -5, of course, is going to give us +15, and then a +1 on the outside times a -7. Well, a positive times a negative is, of course, always negative, so that'll be a -7. We want to know, again, when we simplify, do we ultimately end up with an 8 on the left-hand side? Well, I think we do, right? Because 15 minus 7 does, in fact, give us 8. So we end up with 8 equals 8, which we know to be a true statement. So far, so good. So far, point A works in the first equation. Now we need to test point A in the second equation and see what happens. So I'm going to do the exact same process. So we're going to have negative x, but of course x is being substituted with -5 from the first point, plus 2y, so plus 2y, but again y is going to be substituted for -7. And we want to know, when we clean up the left-hand side, when we simplify the left-hand side, does it equal -9? And hopefully it does. So let's distribute, and again distribute. So a negative times a negative, of course, is positive, so that'll give us +5. And a positive times a negative will give us a negative, so we'll have -14 here. We want to know, ultimately, does that equal -9 when we simplify? And yeah, I think it does, right? If you have $5 in your bank account and you take out $14, well, then we are left with -9 in the bank account, or in other words, we're overdrawn by $9. So we end up with the mathematical statement -9 equals -9, which again is a true statement. So since point A works, meaning it makes both the first equation and the second equation true, then what we can say is that point A, -5, -7, is a solution to the system of equations. All right, so I'm going to let you process that for a second. I'm going to erase the work that's on the screen, so if you need to pause the video here, go for it. And what we're going to do once I erase the work is we're going to do the exact same process all over again, only this time we're going to do the process. We're going to check whether or not the point B, -5, +7, is a solution to the system. All right, so I'm going to erase everything here and we're going to start all over again. So again, we're using the exact same system, so the same two equations, only this time we're substituting in a different point, point B. So let's see if the equation, or rather the point, makes the first equation true. So -3x, but again this time we're going to substitute -5 in for x. So that part didn't change. And then we're going to say plus y, but this time we're substituting a +7 in for x. We want to know, does that equal, when we simplify the left-hand side, do we get +8? That's ultimately what we're trying to verify. So just as we did before, let's go ahead and distribute. Let's clean up the left-hand side here. Negative times a negative, of course, is positive. And then a +1, right, that's an invisible +1 times +7 gives us, again, a +7, so that stays the same. And now, final step here, 15 plus 7. Well, that's going to give us, this time, 22, right? So what we end up with here is the mathematical statement 22 equals 8, which of course we know is a false statement. That is not true. The number 22 does not have the same value as the number 8. And so what we can say here is that because the point B, -5, 7, did not work in the first equation, we don't even have to plug it into the second equation, because in order for the ordered pair to be a quote-unquote solution to the system, it has to work in both equations. So as soon as it fails one equation, you really can stop, because it's not going to be a solution to the entire system. So we're going to say, nope, point B is not a solution to the system. So there we have it. Question 2 from 4.1. We have one verified solution to the system, and then, unfortunately, point B, -5, +7, was not a solution to the system. All right, I'll see you at the next video.